In our previous unit, we talked about congruent figures and how the way that you could know that two shapes were exactly the same size was to know that every single angle was equal to its corresponding angle and every single side had a matching corresponding side. So for instance, if we go back to this warm-up problem and look at it, it says that triangle ABC is congruent to triangle XYZ. What that tells me is that angle A is congruent to angle X, angle B is congruent to angle Y, and angle C is congruent to angle Z. It also tells me that AB, segment AB, is congruent to segment or side XY. It tells me that BC is congruent to YZ. And it tells me that AC is congruent to XZ. So if I know that all three angle pairs are congruent and all three side lengths are congruent, then what I know is that those two triangles must be exactly the same size. But we don't actually have to have information about all 6 pieces. All we really have to have is 3 of the right pieces in the right order. So we're going to talk today just about 2 combinations of those sides and angles that we need to know, and there are actually 5 of them. So 2 of the methods that we're going to use today. The first one is called side, side, side. So I can take 2 triangles and not know anything about the angles. So basically, I can get rid of all of this information. Now, even though I got rid of all that information, it doesn't change anything. I still know that the triangles are the same exact size because they have 3 sides that match. So if you have 3 sides of one triangle that are congruent to 3 sides of another triangle, those 2 triangles have to be exactly the same size. Because what's going to happen is if I give somebody 3 sticks and I give somebody the same size of those 3 sticks and y'all 2 make a triangle, you're going to get the exact same size triangle. There's no way around it. So what we want to look for is, do we have 3 sides? Well, I have a side that matches a side. I have another side that matches another side. And then I have a third side that matches. And so I have a side that matches, a side that matches, and a side that matches. Now, right now, it seems pretty basic, but we're going to get into some other combinations that you'll need to see that are a little more confusing. So I want to decide whether the triangles are congruent. If so, we're going to state the reason, and we're going to complete the congruent statement. So I look, and I see, okay, I don't have any information about the angles, and that's okay. I don't need anything about the angles. What I do know is that DG is congruent to HK. So I have a side that matches a side. And I know that DF matches HJ. So I have another side that matches a side. And then I have FG matches JK. So I have another side that matches a side. So yes, I know that because these triangles have 3 sides congruent to each other, that my triangles must be congruent to each other by the side, side, side congruency theorem. What that tells me is F, D, G. Now, the order matters the way you say this. So look at where F is. F is up between the sides that are marked with 2 and 3, so I need to find the same piece. And you can't always go by how it's laid out. You have to go by your markings. So F matches with J. And then D matches with, D's between the 1 and the 2 sides, so D matches with H. And then we have G matches with K. So I can say that triangle FDG is congruent to triangle JHK because I have 3 sides of one triangle congruent to 3 sides of another triangle. So we look at problem number 2. So I'm looking at triangle ABC. So I'm looking at this triangle right here. And I want to know, is it congruent to triangle ADC? Well, right now we know that triangles can be congruent if we have 3 sides that are the same. So I look, and I don't have. So I look, and I have 3 for AB, but I don't have CD's not 3. No other side is 3. Now AD matches BC. and AC matches AC, right? Because you have an AC on the purple triangle and you have the same AC on the green triangle. So I have two sides that match, but I don't have all three sides that match. So right now, all I have is side and side. And I like to just mark my, when I have sides that match, I put an S on one of the triangles so that I can look at them. So no, I don't have enough information to prove whether these triangles are congruent. And so I can't make a congruent statement if the triangles are not the same size. Then this last one, let's look. So I have AD matches with DC. There's one side. I have AB is marked to be the same length as CB. So I can mark an S. And so then I look. Well, again, don't forget. You can't forget this happens, and this comes up a lot. So anytime you have triangles that share a side, you're going to have that reflexive property. So I know that BD is the same length on both triangles. It didn't change size. If I pulled them apart, BD would still be BD. So I know that those sides are congruent. So yes, these triangles are congruent because of the side-side-side theorem. A, B, D, and you pay attention to the order, is congruent to C, B, D. Now that's pretty straightforward, side-side-side. So let's look at another option. Another option that proves that triangles are congruent is if two sides, and this is what's the important part, and the included angle. So included means it's sandwiched in there. Included angle of a triangle. So here's basically what it looks like. I have a side and I have a side, and then I have this angle right down in here. Now that's opposed to a side, and then I've got this angle over here. Okay, so if I take, actually, let me make these into a triangle so that you can see them. If I have this side, and this side with this angle, see how that ice cream is kind of sitting down inside that cone? Then I've got the same thing if I use that side and that side. See how this angle is hanging out there over at the end like your ice cream spilled out? That is not included. Okay, so this is not included, non-included. Okay, and this is included. Okay, so if you have two sides and the included angle of one triangle congruent to those same pieces on another triangle, then what I know is the triangles are the same size. And so what that's called is side, angle, side. Now look at where the A is. The A is located right smack in between those two S's. Okay, it's included between the two S's. Okay, now if you look, you can have two sides and an angle that's not included, like we had up here, right? But what happens is, because you're able to swing it around, you end up with two different triangles. So if I gave you two sticks and an angle, but I gave you each two different angles, then you might not get the same triangle. So you have to have that angle that's in between for it to work. If it ever comes up SSA, SSA is not a valid way to prove triangles are congruent. You will never ever use SSA to prove that triangles are congruent. Okay, even if it's on the list, you never can use it to prove triangles are congruent. Only SAS. The A has to be in the middle. So let's look at these pictures of these triangles here. So I have triangle ABD, and I have triangle DBC. So I have these two triangles. I notice that I have side AB is congruent to side CB, and I just mark it on one triangle. I have this angle right here, and I like to kind of highlight it so I can see it. So I have a side, and then I have an angle. So now I have an angle, and then I look and say, okay, what else do I know? Well, I know that DB belongs to both triangles if I pull the purple and the green triangle apart. So I know that DB is congruent to DB because of the reflexive property. So look what I have. So then I have S, that side angle side. So it looks like this, side angle side. So yes, I can say that these two triangles are congruent because of side angle side, which means that triangle DAB is congruent to triangle DCB, and the order matters. DAB, and I need to go DCB in that same order. So let's look at everything we know. So let's look, is there any information that we know about this picture that isn't actually marked? Well, I know that this angle, ABD, is congruent to this angle, CBE, because they're vertical angles. Okay, I know that those two are congruent because they're vertical. So I'm going to mark them because I do know it, even though I wasn't told that. So I have a side congruent to a side, so I mark it. It's a side. I have another side congruent to a side, so I mark it. And then I have an angle congruent to an angle. Now the question is, where is the angle? Is it included between the two sides, or is it cast off to the side like it's spilling out? Well, you can see that this angle is snuggled right down there in between those two sides, and so it has to be side angle side. So I can say yes, these triangles are congruent. They are congruent because of the side angle side theorem, and that means that triangle ABD, so ABD, is congruent to, so we need to check how everything is marked. See this right here, how A is marked with, from A to B has the 1 marking, so we need to make that match up. Okay, so we would use then E, so ABD is congruent to EBC. So you have to check the markings and then match things up based on how they're marked. And then let's look at this last one. I have AD is congruent to DC, so I have one side. I have angle A, or ABD. I have this angle is congruent to that angle, so I mark it, and I need one more piece of information, and I notice that DB belongs to both triangles, so that's the reflexive property. So I can say DB is congruent to DB. So I look, so the only option, I have side angle side, or I don't have anything. Okay, if I'm using an angle and two sides, it has to be either SAS but not SSA. So if you look at this, is the angle, is the A in between the two S's, or is it stuck over here at the end like it's falling out? Well, this is stuck over here like it's falling out. Like imagine your ice cream cone laying on its side and your ice cream spilled out. But you can't do SSA. It doesn't prove triangles are congruent, so you say no. And then you can't say triangles are congruent because we just said they're not congruent, so you wouldn't have a congruent statement. Okay, we'll talk later about an option for SSA that it has to do with right triangles, but we're not going to talk about that until later. So let's look at some examples. Remember, we look and mark everything we know. So anything that's not marked. So I've got 3 sides that are marked. I need another piece of information, and I either need a side or I need angles. Well, I don't have any way to get any angles, but I do know sides. So these sides are congruent because it's reflexive. AC belongs to both triangles. So since they are both congruent to both triangles, then I have side, and I have side, and I have side. And so yes, I can say these triangles are congruent by the side theorem, right? Remember right now we have side, and we have side, angle, side. Those are our choices. And if it's not one of those, then it's not anything at this point. Then we would say A, B, C, so do your markings. So A to B to C. So we went from A to B along the 1 mark, so we want to match that up. So A, B, C matches C, D, A. Okay, A, B, C matches C, D, A. So let's look at number 2. Number 2, we have an angle congruent to an angle. We have a side congruent to a side. And we need one more piece of information. And if I look, see, you're going to notice like these same things keep popping up over and over and over. I also have this reflexive property right here, that this side is congruent to itself. Well, I have my side, and I have a side, and I have an angle. Notice where that angle is. It's at the end of one of the sides, like it's been spilled out. It's not here in the middle, which is where we need it to be. So I cannot prove that those triangles are congruent because it is not side, angle, side. Okay, it's SSA, which doesn't work. Okay, so there's no congruent triangles, so you can't write a congruent triangle statement. Now, this one brings up something we haven't talked about again this time, but notice those two arrows, those mean that those two lines are parallel. We're going to need that sometimes. So let's first talk about, I know that these sides, I know that this side is congruent to this side. I know this side is congruent to itself, right, because of the reflexive property. And so now I need either another side, which there's no way for me to know for sure anything about CD and AB, but I did give you these parallel lines for a reason. And the reason I need those is if you highlight those parallel lines and this transversal, what you'll see is those alternate interior angles. And so when you look at those alternate interior angles, you'll see that you've got that angle snug right down there in the middle of that side. So I have a side and I have an angle and a side. So your choices are side angle side or a side side angle. So side angle side is a yes, side side angle is a no. Well, the angle is stuck down in between the sides, so it is a yes, those triangles are congruent. They're congruent because of side angle side. And A, B, D, so look at how they're marked. A, B, D is congruent to D, C, A. So you just look at your markings with how you're going to match everything up. So we have two ways. We don't have to have all 6 pieces of information. We only have to have 3, but we do have to have 3 of the right pieces in the right order. I can have 3 sides of one triangle congruent to 3 sides of another triangle and know that the triangles are exactly the same size. Or I can have 2 sides of a triangle congruent to 2 sides of a triangle and the included angle, that's the important part, the included angle of those 2 triangles be congruent. And if I have those 2 things, then the triangles can be congruent by side, angle, side. SSA never works, okay? Well, it never works unless there are particular situations where SSA works. But right now, we never say SSA as a reason that the triangles are congruent. We have to say something else